Imagine this. The sky is no longer blue. The horizon glows like molten metal. The air shimmers, not with warmth, but with warning. A sunrise that looks more like the birth of a new sun. Waves of fire ripple across the heavens as shadows disappear forever. This isn't a sci-fi scene. This is what will happen here, on Earth, in our solar system, when the sun decides it's time to die. What you're about to see is the true, unavoidable ending of everything we know. But to understand the sun's final catastrophic moment, we must first understand how it was born and how it lives. 4.5 billion years ago, in an unremarkable corner of the Milky Way, a massive cloud of gas and dust slept in silence. Then, something shook it awake. A supernova's shockwave slammed into the cloud, compressing it like a cosmic heartbeat. Gravity took over, clouds collapsed, spun, and flattened into a disk. And at the center, a glowing infant was forming, a protostar. It wasn't bright yet. It didn't shine, it only heated and waited. Then one moment changed the galaxy. Its core ignited, hydrogen fused into helium, and the sun took its first breath. A star was born, and with it, the future of every world that would orbit it. We look at the sun and see a glowing circle, but beneath that surface lies one of the most violent engines in the universe. At the core, temperatures reach 15 million degrees Celsius. Here, hydrogen atoms are crushed so tightly that quantum mechanics lets them tunnel into each other and fuse. Every second, the core turns 600 million tons of hydrogen into pure energy. This energy then begins a staggeringly slow journey outward. In the radiative zone, a single photon can take up to 170,000 years to escape, bouncing around like a prisoner in a maze. In the convective zone, giant bubbles of plasma, the size of continents, rise and fall in boiling patterns. At the photosphere, the sun finally releases its light, but the surface is far from peaceful. Sunspots, magnetic storms, flares, and plasma arcs stretch thousands of miles high. And sometimes, the sun lashes out with coronal mass ejections, giant plasma clouds that can shut down our power grids. Our star is not calm. It is barely controlled chaos wrapped in fire. Every 11 years, the sun enters a new cycle. Its magnetic field twists, tangles, snaps, and flips. During the solar maximum, the sun becomes more violent, unpredictable, and dangerous. Auroras spread, radio signals fail, satellites struggle, and all of this is driven by a thin hidden layer deep inside the sun, the tachocline, where its magnetic engine churns. Understanding this cycle is the key to predicting solar storms that could affect every piece of technology we depend on. We imagine the solar system as a peaceful clock, but new simulations show it's much closer to a cosmic Jenga tower. As the sun orbits the Milky Way, stars pass dangerously close to our system. Most fly harmlessly by. But even a distant pass, just a few light years away, can disturb comet clouds and nudge planets. Recent studies show Mercury has an increased chance of being thrown into the sun. Mars could be ejected into interstellar space. Earth has a tiny but real chance of orbital chaos. The outer solar system could unravel first, like loose threads. We like to think our place in space is stable, but gravity, given enough time, never guarantees anything. Fast forward 5 billion years. The sun runs out of hydrogen. The core collapses. Temperature spikes. Hydrogen ignites in a shell around the dead core, and suddenly, the sun swells. Bigger, brighter, redder. The sun becomes a red giant, growing so huge it will reach where Earth orbits today. Mercury vaporized. Venus consumed. Earth uncertain. But long before the sun reaches us, The rising heat will boil away the oceans, strip the atmosphere, melt the crust, erase every trace of life. Earth may survive as a rock for a while, but life will not. Inside the swollen sun, new chaos begins. The dead helium core heats until helium fusion ignites in a furious flash. For 100 million more years, the sun burns helium peacefully. But then, the fuel runs out again. What comes next is its final breath. The sun pulses violently, its outer layers peel away and drift into space. A ghostly bubble of glowing gas forms around the exposed core. This is a planetary nebula, the sun's last masterpiece, a tombstone of colored light. At the center, the heart of the sun remains, a white dwarf, no bigger than Earth, hotter than any furnace, slowly fading for trillions of years. The sun will destroy us, but it also created us. Everything inside your body, your bones, your blood, your breath, was forged by stars exactly like ours. We are temporary visitors to a system ruled by a star with a beginning, a middle, and an end. And even though the sun will one day lose its fire, it has given us enough time to rise, imagine, and maybe someday leave this fragile world behind. Because if humanity learns anything from the sun, it's this: all stars die, but life doesn't have to die with them.